Hello everyone, welcome back to my channel. So in this video, I'm going to start module 1 of elements of electrical engineering for first year's video students. So module 1 can observe it has two chapters. One is DC circuits, another one is electromagnetism. DC circuit which has Ohm's law, Kirchhoff's laws, analysis of series, parallel, and series parallel combination circuits. And also it has power and energy with a simple numerical. Okay. So without wasting time, let's move on to the first concept, that is Ohm's law. So before that, DC circuits means you're applying DC supply, direct current, unidirectional device. Okay. So DC you are applying to the conducting material, say it as a resistor, so that George Simon Ohm, he introduced Ohm's law, and he defines or he states Ohm's law as, if you are considering any conductor, so if you are giving supply, or else if you are giving supply to the conductor, that supply voltage that will be directly proportional to the current flowing through the conductor by considering temperature and any other physical parameters constant. So according to textbook, you can see it states that the current flowing through the two ends of conductor, now resistor is a conductor, current flowing through the two ends of this conductor is directly proportional to the voltage across the 2 points, provided its temperature and other physical parameter remains unchanged. That is nothing but I is directly proportional to V. Okay. So that to remove this proportionality, to remove this proportional, so you're introducing proportionality constant, that is nothing but R. R is proportionality constant. So that you are defining voltage V equals to R into I, whereas R is proportionality constant. You can call that as a resistance. Resistance is a property by virtue of which always opposes the flow of current. Okay. So that you can see the limitations of Ohm's law. So it is not applicable for nonlinear devices. So what are nonlinear devices? Such as semiconductor devices and zero diodes. And also it is not applicable to non-metallic conductors. So again, what are non-metallic conductors? Like silicon carbide, where the following relation is applicable. That's nothing but V equals to K into I to the power M, where K and M are constant, so that V equals to I. Okay. Similarly, Ohm's law cannot be applied to arc lamps, whereas in the case of arc lamp, there will be a variation of temperature. There is no constant temperature, so that it cannot be applied. And last point, it does not hold good where the temperature rise is rapid in some metals. So it can be applied to only constant temperature metals, so that if there is a variation of temperature, then you cannot apply Ohm's law. Okay. So these are all the limitations of Ohm's law. Similarly, you can see about proportionality constant R, that is the resistance. So resistance is a property by virtue of which always opposes the flow of current through it. So that this resistance of the conductor, that is directly proportional to the length of wire L and inversely proportional to area of cross section A. So to remove this proportional, we are introducing proportionality constant, that is rho, whereas rho is specific resistance or resistivity of the material. So that you can write R equals to rho L divided by E, or you can also write rho equals R A divided by L, whereas unit of SI unit of rho is, we can define as SI unit of resistor is ohm, and for area it is meter square divided by length will be measured in terms of ohm. So that meter and meter will get cancelled. The SI unit of resistivity is ohm meter. Okay. Similarly, the next one is electric current. So these basics you should know the definition, or else you need to understand what is current, what is resistance, what is voltage. Then you can easily understand about Ohm's law, and then you can easily apply Ohm's law to the circuits to get unknown parameters. So that electric current is nothing but the rate at which electrical charge is transferred across a point in a conductor is called as the current through the conductor. In general, you can say it as rate of change of charge is nothing but current. And SI unit of current is ampere. You are representing as capital letter A. Similarly, electric potential. So electric potential is nothing but voltage. You can say it as voltage or electric potential. The work done to bring a unit positive charge from infinite to that point you can call it as electric potential. The unit of this is volts. Whereas the potential difference is nothing but it's between any 2 points of a charged conductor. So we can define it as any amount of work that has to be done to bring unit positive charge from one point of lower potential to other point of higher potential is called as potential difference, and unit of potential difference is volts again. And next, power. The rate at which work is done is called power. You can define P equals to V into I is a formula of power. Whereas in case of DC supply, the power factor is always 1. So that you are writing P equals to V into I itself. By Ohm's law, you can substitute, you know that V equals to I into R. If you substitute the value of voltage in this, you can get it as I square into R. Similarly, if you are substituting the value of current in this equation, you can get V square divided by R. So these three are the formula of power in case of DC. Similarly, one more parameter that is energy, the capacity to do work. The capacity to do work is nothing but energy. Okay. So these are the points, Ohm's law and limitations, and you should know some basic definitions of current, voltage, resistance, and property of resistance. So next move on to the Ohm's law triangle. To find V, can observe here by considering this Ohm's law. If you want to get V equals to I into R, suppose if you want to find I, you can get V divided by R, and R you can get it as V divided by, easily you can remember the formula. Okay. And you can see with respect to current and resistance, you just see the relations between resistance, current, voltage for known values. Suppose if you know the value of current and resistance, you can calculate voltage equals to I into R, and power you can use I square into R, because you only know the value of current and resistance. You cannot use here V into I or V square divided by R, because we don't know the value of V. Similarly, if you know the value of voltage and current, you can find resistance and you can find power, that is V into I, only if you know the value of voltage and current. Similarly, if you know the value of power and current, that is if you know P and I, you can calculate R with the help of power. That's nothing but you know that P equals to I square into R. So with the help of that, you can calculate R equals to P divided by I square. And also, you know that power which is given by V into I, so that you can also calculate the value of voltage V equals to P divided by I. Similarly, if you know the value of voltage and resistance, you can calculate current and power. If you know power and resistance, you can calculate current and voltage. If you know voltage and power, you can calculate resistance and current. So this matrix table you should know while solving the problem. What parameters they are given and what parameter you have to find in a numerical. Okay. And the next you can see, if you are connecting a series parallel combination, before that, this I'll explain later. First you see resistances in series. So let us consider three resistors, say it as R1, R2, R3, which are connected in series across voltage source V, and current starts to flow. I starts to flow through R1, R2, R3, and there will be a voltage drop across R1, R2, R3. The condition for series circuit is whenever the supply which is given, current flowing through the R1 is also I, and R2 is also I, R3 is also I, so that in case of series circuit, current flowing through the circuit which will be always same for all parameters. Okay, but voltage which divides across each parameter in case of series circuit. So that you can see here the voltage divides, but current same. So from this circuit, let us consider the total voltage V which is given by divided values of voltage. That is voltage drop across R1, that is V1, voltage drop across R2, that is V2, plus voltage drop across R3, that is V3. Then you can get the value of equivalent value of resistance. So whereas total voltage V is given by total current I into total resistance R, that is nothing but equivalent value of resistance I into R equivalent. Okay, total V equals to I into R equivalent. Similarly, V1 how will write? V1 which is given by current flowing through R1 into R1. That is nothing but current flowing through R1 is I into R1 is V1. Similarly, V2 is I into R2, the same current which is flowing. V3 is I into R3. So that is substitute these values in the above equation A, you can get I into R equivalent equals I into R1 plus I into R2 plus I into R3. So current is same, so that I is a common. So by taking I as a common, you can get R equivalent equals R1 plus R2 plus R3 for 3 resistances in series. Similarly, if you are connecting 4 resistors as series, then R1 plus R2 plus R3 plus R4. So you can easily get the equivalent value of resistances for series circuit is the addition. Okay. So like that you can get the equivalent value of resistance for series circuit. Suppose if you connect these resistances in parallel, consider R1, R2, R3. Can see, consider R1, R2, R3 which are connected in parallel across voltage source. The total current I starts to flow and which divides into the sub branches as I1, I2 and I3. So now what is the condition? In case of resistance in parallel, current divides. In case of series, voltage divides. In case of parallel, current divides, but voltage is the same. Voltage across pure parallel combination, that will be same. That is nothing but voltage across R3 is also V, and voltage across R2 is also V, and voltage across R1 is also V. But total current I, that is given by total current equals to sum of divided currents. That is I equals I1 plus I2 plus I3. So that you can substitute the value of I. You know that total voltage V is given by I into R equivalent. Okay. So that I can write it as V divided by R equivalent. Similarly, I1 how will write from this branch. So I1 which is given by voltage across R1 is V divided by resistance in that branch is R1. So that V divided by R1. So I1 is given by V divided by R1. Similarly, I2 is given by V divided by R2 and I3 which is given by V divided by R3. So substitute this value to this equation A. You can get V divided by R equivalent equals V divided by R1 plus V divided by R2 plus V divided by R3. V divided by R3. So by taking voltage as a common, you can get 1 by R equivalent equals 1 by R1 plus 1 by R2 plus 1 by R3. So this is the equivalent value of resistance if 3 resistances which are connected in parallel. Suppose if you are connecting 2 resistors in parallel, so for 2 resistors, how will write? For 2 resistors, for two resistors. So 1 by R equivalent equals 1 by R1 plus 1 by R2. Let's take LCM. So by taking LCM, what do you get? 1 by R equivalent equals R1 plus R2 divided by R1 into R2. So that if you want to get R equivalent, inverse of this, or else 1 over R equivalent. You are getting the value of 1 over R equivalent, but we want to get the value of what? R equivalent. So that R equivalent equals R1 R2 divided by R1 plus R2. R1 plus R2. This is the equivalent value of resistor for two resistors. Okay. So if what will be the difference between series and parallel resistance now? In case of series resistance, current same, voltage divides. In case of parallel, voltage same, current divides. Okay, so that where there is a voltage divides, there you need to apply a rule called voltage divider rule, so that in a series circuit to find the value of divided voltage, you are applying voltage divider rule. So to know about this voltage divider rule, first you just check. Let us consider two resistors or else two resistances R1 and R2 which are connected in series across voltage. So that voltage across R1 is V1, that is given by I into R1, and voltage across R2 is V2, that is I into R2. So that you can get total voltage V equals to V1 plus V2. Okay. So you need to find the value of V1. So that V1 is given by I into R1. So V1 which is given by I into R1. So that if you want to know the value of V1, you should get the value of I. So that to get the value of I, you defining Ohm's law V equals to I into R equivalent. Total voltage equals to total current into total resistance. So that I you are getting I equals to V divided by R equivalent. Whereas whereas two resistances which are connected in series, so that R equivalent is R1 plus R2. So V divided by R1 plus R2. You can see here I have written that I. So I equals to V divided by R equivalent. This is equation number A. If you want, you can write it as A. So now we substitute this value to V1. We know that V1 equals to I into R1, whereas I is V divided by R1 plus R2. By substituting this, you can get V1 equals to V into R1 divided by R1 plus R2. It is nothing but the voltage divider rule, which says that voltage appearing across one of the resistance, that is series resistance, is the total voltage times the ratio of its resistance to the total resistance. It is nothing but total voltage into V1 is given by total voltage into the same resistor value divided by sum of resistors R1 plus R2. There are two resistors, so that sum of these two resistors. Similarly, V2 how will write? So V2 equals to total voltage into the same resistance, that is R2 divided by sum of resistances R1 plus R2. So this is the formula for voltage divider rule. Similarly, you have one more rule for parallel circuits, that is current divider rule. So if you want to know about current divider rule, so you should know the total current IT, it is IT. Total current is dividing it as I1 and I2. I1 which flows through R1 and I2 which flows through R2, and total voltage is V. Voltage across R1 is voltage across R1 is V, and voltage across R2 is also V, because it's a pure parallel combination circuit. Okay. So let's consider let's consider uh, I1. We know that from circuit, so I1 is given by V divided by R1. So if you want to get a divided current, that is, if you want to get the value of I1, you should get the value of V. So how will write total voltage V? But total voltage V equals total current into total resistance, that is R equivalent. so that you can get V equals I into R equivalent is nothing but there are two resistances which are connected in parallel, so that R equivalent is given by R1 into R2 divided by R1 plus R2. This is V. Substitute equation 1 in equation A, you will get current divided formula. So that I1 equals V is nothing but I into R1 R2 divided by R1 plus R2 into 1 by R1. So R1 and R1 will get cancelled. You can get I1 equals total current I into opposite resistance I into, see here I1 is given by total current I into and opposite resistance R2, you can see here R2 divided by total resistor R1 plus R2. So current divided, which says that the branch current is given by total current into opposite resistance divided by sum of resistances. Okay. Similarly, how will write I2? I2 which is given by total current I into opposite resistance is R1 divided by sum of resistance R1 plus R2. And total current also can rewrite it as I equals to I1 plus I2. So with the help of these three formulae, you can find the value of currents, total current or branch currents. Okay. So these are about voltage divide rule and current divide rule. Voltage divide rule says that and the total voltage into same resistance divided by sum of resistance, whereas current divide rule says that total current into opposite resistance divided by sum of resistance. Okay, I hope you're understanding the concept. So in next video, let's solve series parallel combinational problems, and also you can easily understand how to solve the problems and all with the help of these basics. So if you really like this video, please do subscribe and share maximum. If you are having any doubts regarding this, feel free to write in the comment box. Thank you so much for watching this video. Have a nice day.